Hello there, design engineers. Welcome to DesignCon. I'm Brad Griffin, part of the Sigrity team here at Cadence. And today we want to show you a little bit about our power integrity solution, help you understand how you can use design tools from Cadence to basically optimize your power delivery network for PCBs, packages, and even into the chip. We basically focus on a system design enablement solution. So starting with Sigrity PowerDC, which is probably one of the most commonly known DC analysis tools available today. PowerDC is a flagship product of the Sigrity product line, and it has many different ways to be able to view electrical results. We have 3D plots that can show us where the vias that are carrying the most current are. It can show us 2D plots, which shows us where the hotspots are, where you're going to have your current choked off, where you're going to have the highest IR drop. And so the DC analysis tool is really one of the things that enables us to make the first steps in enabling the most optimized power delivery network. Another product that we have is called PowerSI. I'm not actually going to show that here in this demo, but PowerSI is focused on doing AC analysis. So between the DC and the AC analysis, we cover really the basics in power delivery network analysis. So again, PowerDC is a tool that's very popular. One of the things that we've done at Cadence since we acquired Sigrity is we've integrated it very closely with the Allegro product line. So we now have something called Allegro Sigrity PI. So Allegro Sigrity PI uses that PowerDC engine that we were talking about for DC analysis, and it links to the Allegro environment where it actually can make changes to the design. So the PowerDC environment says here's where those vias are that are carrying too much current, points you directly to them, and then allows you to go to the Allegro environment and make changes to the design and then reanalyze that very quickly. It's actually something that we talk about in our press release that came out just today as part of the Allegro, as part of the Sigrity 2016 release, is new enhancements that we have that improves the integration between PowerDC and Allegro in this product Allegro Sigrity PI. So here we see all the DRC markers being displayed in Allegro as they've been imported into Allegro as a result of PowerDC saying these are violating your electrical constraints. Another very popular tool, especially with those customers that are cost conscious, is something called Sigrity Optimize PI. Because as we all know, decoupling capacitors add costs to the design. But choosing the right decoupling capacitor scheme, A, can improve your overall performance, but then B, can actually, if it's done effectively, can reduce the cost of your design. And who wants to spend more on their actual design than they actually need to? So Sigrity Optimize PI provides some very basic checks that say somebody like a PCB designer could run that says, let me see which capacitors are being the most effective. And that's the loop inductance check that we're showing right here. So the loop inductance check will point out to the capacitor that actually has the highest amount of inductance. And we all know if there's too much inductance, the capacitor basically becomes useless. So we want to figure out where those areas are and make sure it's still within the spec. So the environment that we have for Sigrity Optimize PI allows you to look at the report, find out where the loop inductance check had the highest values. So here's this graph that shows us, and then we can go and we can make those changes in the design. Another thing that Optimize PI, probably the most common way that Optimize PI is used, is all the capacitors you have on your design, it actually looks at the values of those capacitors and says, is there some other scheme that we could use to improve the overall performance? So it runs through basically a sweep and decides, here's the best scheme that you could use with these capacitors. Many times people are able to remove 50% of the capacitors from their designs and still have improved performance. And what's really great about the tools of today is now that information can be back annotated to the Allegro environment. So you come up with the optimized scheme, now you don't have to put it down in an Excel spreadsheet and hand it off to your PCB designer. You can back annotate that right into Allegro and meet the capacitance. Last but not least, Optimize PI has an ability to say, well, all my capacitors, I still don't meet spec. So where can I add capacitors to be the most effective? And that's what this workflow that we're going through right now is looking to see each capacitor. So that kind of is a nutshell of what happens with the power integrity tools. Now all that carries over to the signal integrity environment as well. So we have a tool called Sigrity System Explorer, which doesn't just look at the signal, the connectivity, but also looks at the power and ground. So if you look at this right here, you see us connecting signal, power, and ground, connecting the VRM to that signal. And so when we do our analysis, it's not just looking at the signal integrity alone, it's looking at the power delivery network. So here's an example where we've got an S parameter that's being used for the interconnect. So we're connecting all the signal, power, and ground from driver to receiver. So we're looking at that S parameter model. Now when we go to simulate, we're not just simulating the signal, we're simulating signal, power, and ground. And the advantage here is with multiple connections, you're seeing the effects of simultaneous switching noise. Multiple signals are switching, and it's not just looking at the signal, but here you see the power network, and now this result here includes simultaneous switching noise. And that's the power-aware signal integrity analysis that Cadence is actually famous for. So thank you very much for your time. That wraps up my discussion today. Hope to see you at DesignCon next year.